Let's continue with the next problem. Feedback control system has the open loop transfer function g of s into h of s that equal to k divided by s into s plus 4 s square plus 4s plus 20. Plot the root locus for k equal to 0. So that is the step number 1. As we know that same as previous problem, step 1. So identify the poles and zeros. Here number of poles. So this is s into s plus 4 means s square plus 4s into s square plus 4s plus 20. So we will get the number of poles will be 4. So in numerator there is no s coefficient, zeros will be 0. So that is poles equal to 4, zeros is 0, n equal to p equal to 4, that is 4 branches. So the number of poles value is 0. So then you have to equate it to 0. So s plus 4 equal to 0, s equal to minus 4. Then from this quadratic equation, s square plus 4s plus 20. Okay, so 20 can be divided into 5 4 is 20, or else you can use 10 2 is 20. So it's not getting, it's unsolved quadratic equation. So hence we can use standard equation minus b plus r minus under root b square minus 4ac divided by 20. You will get the pole minus 2 plus r minus j4. Then you have to sketch poles on, mark the poles and zeros on real and imaginary axis. So here we can mark the first pole is 0, next pole is minus 2 plus r minus j4, minus 2 plus r minus j4, and the last pole is minus 5. That is the step number 2. Then the step number 3, you have to find the angle of asymptotes. So this is the step number 3. We know that the formula theta is equal to 2q plus 1 into 180 divided by p minus z. So put q equal to 0 to 3, because p minus z branches equal to, you will get 4 branches. So we have to find the 4 angle, theta 1, theta 2, theta 3, theta 4. So 315, 225, 135. Then step number 4, find the centroid. Centroid is summation of real parts. Same, use the formula, substitute the values, real parts of poles. Suppose if the pole having minus 2 plus or minus j2 means this is the real part and this is imaginary. So we have to consider the real values here. So we will get the minus 2. Then step 5, find the breakaway point. So 1 plus g of s into h of s equal to 0. Substitute the values. So then you will get this equation. So this equation you can rewrite in terms of k. You will get the k equation. Then differentiate with respect to s. So 4s cube minus 24, 72, 80. So then you have to equate it to 0. So take minus side outside. So we'll get these values. Then here we have to find the roots of this cubic equation. So s equal to minus 2 and s equal to minus 2 plus r minus j 2.45. So if you are solving this cubic equation, you will get these two roots. So this one is the real part. So you can directly find the breakaway, either this is the valid breakaway point or not, you can easily calculate. But the thing is, compared to problem number 2, this is somehow different. Here the breakaway point having the complex value. So if it is having the complex value, what is the procedure to check? Validation or valid breakaway point. So you can use the angle condition. So angle of g of s h of s at, so minus 2 plus r minus j 2.45. So that equal to plus r minus 2p plus 1 into 180. So that will be shown here. So just observe here, k into, just observe here, we will get this equation, k plus j0 divided by s into s plus 4 into s plus 2 plus j4 into s plus 2 minus j4 at s equal to minus 2 plus j4. So we will get this one. Then you have to solve, apply the angle condition. Angle of k plus j0 divided by angle of, we get this values. minus 2 plus or minus j 2.45 an angle. So minus 2 plus 4 minus 2 plus j 2.45 plus 2 plus j4 to minus 2 plus j 2.45 plus minus 2 j4. Then you have to convert this rectangle to polar. Only consider the angle. So here the k is the constant. K is the constant. So we will get k plus j0. If I convert it into polar, we will get 0 degree. Then this term minus 2 plus j 2.4. If I apply the converted into rectangle to polar, we will get at 129. Only consider the angle. So from this term only consider the angle, from this term consider the angle, from this term consider the angle. If we are adding all the angles, we get 180 degree. So if it is equal to 180 degree, then it satisfied angle condition. Okay. So at s equal to minus 2, k will get positive. So both the roots are valid breakaway points. Then you have to find the point of intersection. So point of intersection is this one, s power 4 8s cube. Consider the characteristic equation to find the point of intersection. So same thing here, a0, a1, a2, a3, a4. So this is the first row element is e1, a0, a2, a4. This is the second row element a1, a3, a5. So apply the RH rule, that is RH criteria, we will get the value of k. So where we get the value of k, consider the previous equation which is called as auxiliary equation. So that will be calculated here, a of s equal to 26s square plus k. So put k value, k equal to 260, then we will get s. So therefore s equal to plus or minus a 3.162. Then you have to find angle of departure. So to calculate the angle of departure, I can use this method. So first pole, draw the slope line, mark the point P, draw one slope line from first pole, then draw the one more slope line from second pole, draw the one more slope line from the third pole. So we get the values of pi p1, pi p2 and pi p3. Okay. Then after finding these values, you have to sketch the root locus. So to sketch the root locus, here we will get the complete root locus. So to sketch the root locus, just observe here. After sketching of root locus, you will get this graph. How to get this graph means you can get the complete values. So we will get, just observe here. How to plot this graph means you can use the normal method. So look at here, how to get this graph. Draw the line, the x-axis, and draw one more line on y-axis. First I will mark the poles. First pole, second pole is minus 2 plus j2 minus j2, then minus 4. Okay. Then the centroid. So what we get the centroid is we get the some values. So that is centroid is, that is minus 2. So minus 2 is the centroid. So we can mark the draw the angle, that is theta 1, that is theta 2. Take the protector, consider this is the centroid, draw the angle. Theta 1 is 45 degree, then theta 2, then theta 3, then theta 4. Okay, so that will be done here. Just look at the graph. Then you have to mark the breakaway points. So the first breakaway point is, we will get the values, that is valid breakaway point. So valid breakaway point is minus 2, that is the first breakaway point, and second breakaway point is this. So this is the second valid breakaway point. Okay, so while plotting the graph we get this problem. So here valid breakaway point, then you have to calculate the angle of departure. So angle of departures, we will get the angle of departure is some values, that is angle of departure here. So we get the angle of departure is 116. Clear? So we will get the angle of, not 116, we get the angle of departure. So that angle of departure is, we will get this value, that is angle of departure we will get 140 degree. Clear? So for this 140 degree of angle of departure we have to plot the graph. So mark this graph like this. So take the protractor, draw the angle of departure. So here also you can draw the angle of departure, and that is 140 degree, pi d. This is pi d, 140 degree. Then the root locus will start from this point and mark the point of intersection. Point of intersection will get SR minus J 3.16. This is 3.16. Here 3.16. So when you draw the graph means we will get like this. So we will get the graph like this. 0.86. So that is angle of departure will be like. So this is breakaway point, angle of departure. So we get this point. So meet at the point. So the root locus will start from here and meet the angle of departure, that is -2 plus or minus j 2.4. So breakaway point is, for this case, the special breakaway point. The value of breakaway point is, we will get -2 plus or minus j 2.45. So let us sketch the graph, we will get like this. Okay, once again I will tell you, this is points, mark it. This is the centroid, draw the slope lines. Okay, then you can draw the angle of departure. This is pi d, this is pi d, that is 140 degree, 90 degree. So here in this case we will get the angle of departure is 90 degree. Okay, then breakaway point is -2 plus j 2.45. Somewhere here we will get -2 is here, plus j 2.45. Okay, then root locus will start from this point, meets the breakaway point and touches point of intersection and moves to infinity. So here also same thing. So here also same thing. This is about the problem number 3.